In this video, we will talk about Docker Desktop. We will install Docker Desktop on a Windows machine, run a Hello World container on Docker, enable Kubernetes on Docker Desktop, and run a Hello World pod on Kubernetes. Docker Desktop is a one-click install application for your Mac, Linux, or Windows environment that enables you to build and share containerized applications and microservices. This is the Docker Desktop user interface. It makes it easy to develop and run containers on your development machine. It enables you to view and manage containers, images, and volumes. Under Containers, you can start, stop, pause, or delete a container. Under Images, you can view image info such as its size, run a container of the image, delete the image, etc. Under Volumes, you can create and manage volumes that can be used by your containers. The whale icon at the bottom left indicates whether the Docker engine is running, and below it is the Kubernetes icon, which indicates whether Kubernetes is running. Check the resources page for this lecture to find the links to Get Docker Desktop and Docker Desktop documentation. In this lab, you will install Docker Desktop on your Windows machine. Go to your web browser, type get docker, click on Docker Desktop for Windows, click here to download the installer, and check the system requirements. It requires the latest version of WSL, that's Windows Subsystem for Linux, so let's make sure we have that. Launch the Windows PowerShell and type this command WSL --update. This will update WSL to the latest version. Then type WSL -L to list the available Linux distributions. You can see here it says Windows Subsystem for Linux has no installed distributions. So let's install one. Type WSL --install. And this will install the Ubuntu distribution, which is the default distribution for WSL. You need to enter new Unix username. And a password. And this is the terminal for the Linux distribution under WSL. You can issue any Linux command, for instance, pwd will print the working directory. Now go back to the installation of Docker Desktop, click on the installer, accept the default configuration, and give it a minute to unpack and install Docker Desktop. Installation succeeded. Let's launch Docker Desktop from the Start menu. Accept the license agreement. Skip the survey. And Docker Desktop is going to take a minute to start. Skip the tutorial, and you have the list of containers, images, and volumes. All these are empty now, we didn't run any containers. And here you have this green button with the whale on it, and you mouse hover it, it says engine running, which means the Docker engine is running. You can close this window and Docker Desktop will remain running in the background. You can bring it back anytime from the Windows system tray. Now let's launch the Ubuntu terminal from the start menu and check the Docker version. Type docker -v, and we have Docker successfully installed with version 20.10.23. In this lab, you will run a Hello World container on your own Docker desktop environment. Let's get started. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Start by launching the Ubuntu terminal from your Windows Start menu. I have the terminal already available, so let's run this command: docker run hello world. Notice this message here: unable to find image hello world locally. So because Docker did not have the image locally, it pulled it from the Docker Hub repository and created a container based off it, and this container printed the hello from Docker message along with this useful information, which basically says that Docker had to download the image, run a container off of it, and print the output to your terminal. Run the following command to list available containers in a running state: docker ps. You get an empty list because docker ps lists containers in a running state only. Run docker ps -a to list all containers including exited ones, and you can see that the hello world container has exited 52 seconds ago. This is because all the hello world image does is execute a program called hello, which prints the output message then exits. Think of running a container as running a task. The container runs a single command, and when the command exits, the container exits too. Visit the Hello World images page on Docker Hub to learn more about it. You can find a link to this page in the resources attached to this lab. Let's have more fun with more Docker commands. To start a Docker container that exited, use the docker start command. You will need to specify the -i flag to run the container in an interactive mode, which is necessary to print the output of the container to our terminal, and you will need to identify the container either by ID or by name. So let's specify the ID of the container. And the hello world container was rerun again. Hello from Docker. Notice that this time Docker did not say that it's unable to find the hello world image because the image is already available locally. Use the docker images to list the available images in your Docker environment. If you switch to Docker Desktop, you can see the container under the list of containers based on the hello world image. And if you go to images, you will find the hello world image available here. Going back to the terminal, let's delete the container. You can use the command docker rm to remove a container that is in a stopped state. Again, you need to identify the container by ID or by name. So let's specify the ID of the container. The ID is printed back, which means that the container has been deleted. So docker ps -a gives us back an empty list because the container is deleted. Run the command docker image prune -a to remove images not currently used by any container. This will remove all images without at least one container associated to them. Are you sure you want to continue? Yes. And notice the total space reclaimed, 13.26 kilobytes, so this did free up some space on the server. To see a list of the commands we tried today, check the sample commands.pdf file in the resources attached to this lab. Also check a nice Docker command line interface cheat sheet in the resources attached to this lab. Now take a look on Docker desktop again. You can see that the image is gone and the container is gone because we just deleted them. That's it for this lab. You have successfully installed Docker, ran a Hello World container, and ran several commands to manage your Docker environment. In this lab, you will enable Kubernetes in your Docker desktop environment. Let's get started. First, you will need to enable Kubernetes in Docker desktop. So go to Settings, click on Kubernetes, select Enable Kubernetes, apply and restart, install, and wait for a minute for Kubernetes to be enabled. Notice at the bottom left there is a new icon for Kubernetes, and if you mouse hover it, it says Kubernetes running. So Kubernetes is installed and running successfully. Let's confirm that our Kubernetes setup is successful. Launch the terminal. Kubernetes provides a command line tool for communicating with a Kubernetes cluster, and this tool is named kubectl. So simply type kubectl get node, and this lists the nodes available in the cluster. This confirms that our Kubernetes setup was successful. In case you get an error that the connection to the server was refused, just restart your machine and try again, and this should fix the problem. In this lab, you will run a Hello World pod on your Kubernetes cluster. Let's get started. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Also, check a nice kubectl cheat sheet in the resources attached to this lab. To run a Hello World pod, type this command on your terminal. Let's go through the contents of this command. kubectl is Kubernetes' command line tool for configuring a Kubernetes cluster. Run test. This launches a pod with the name test. A pod is the smallest deployable unit of computing that you can create and manage in Kubernetes. A pod encapsulates one or more containers. More on that later in this course. Restart equals never. Kubernetes keeps restarting a stopped pod by default, so this option instructs Kubernetes not to restart the pod if it exits. Image equals hello world. Container image is hello world. Finally, the IT flags. This runs the pod in the foreground so that its output is printed on the host terminal. Let's go ahead and run this command. A pod with one container of the Hello World image was run and printed its output on your terminal. Hello from Docker. Then the pod exited because the Hello World container prints that message and exits. Let's check the existing pods in the Kubernetes cluster. Type the command kubectl get pod. There is one pod in the completed status because the test pod have exited after the hello world container exited. Get more information about the pod using the kubectl describe pod command. The describe command gives extensive information about the pod, such as the node it runs on, the pod's IP address, its status, succeeded, the container specification, etc. Let's now delete the pod. kubectl delete pod test. The pod is deleted, so if we run kubectl get pod, there are no pods available. Now let's run the pod again and delete it immediately, this time after it exits, by adding the --rm option. The pod has been created, the container is run, and we get the message hello from Docker. But notice that at the end it says pod test deleted. So if you type kubectl get pod, we don't have the pod here. So this is an example if you want to run a pod and get its output and delete it immediately after it exits. That's it for this lab. You have successfully installed Kubernetes, ran a hello world pod, and ran several commands to manage your Kubernetes environment. Thank you for your time, and I will see you in the next lecture.